We know that around magnets, there's always going to be a magnetic field. This magnetic field happens to go from the north pole of a magnet to the south pole in a fashion that looks like this. So if you can imagine the magnetic poles to be north and south like I've drawn, the magnetic fields go from the north side to the south side on the outside, while on the inside they go from north to south. If a moving charge was to enter this magnetic field, what would happen is if this moving charge is perpendicular to the direction of the magnetic field line's movement, then it would experience a maximum force. And you'll understand in a moment why, but nonetheless, if it's moving in a magnetic field and it's perpendicular to it, it will experience a maximum force, which is known as F max. However, if it's moving parallel to the direction of the magnetic field, then in that scenario, it would experience no force at all. And if it's not moving, or if it's static, in other words, it will not also experience any force. Now, how do we calculate the magnetic force on the charge? We use the equation F equals to QVB sinus of theta, where theta is the angle between the direction of the charge's movement and the magnetic field line. Now, if that's the case, what is Q, V, and B? Well, Q is simply the amount of charge, which is measured in coulombs. V is the velocity of the electric charge, which is measured in meters per second. And B is the intensity of the magnetic field, or the magnetic field density. So it's the intensity of the magnetic field. Now, the intensity of the magnetic field is measured in the unit Tesla, and you might see the units of megatesla quite often because we usually use mega or giga sometimes in proportion with what the Tesla itself is. So it's worth noting that mega stands for 10 to the power of 6. Shown with a capital M, not to be confused with milli, which is 10 to the power of -3, which is a lowercase m. All right, so let's go ahead and take a look at how we can find the magnetic force for a charge that is moving in parallel with a specific velocity, but in parallel with the magnetic field lines. It turns out if a charge is moving in parallel with the magnetic field lines, then experiences no force, because the angle between the magnetic field line and the charge is 0, and we know that the sinus of 0 is 0, so the force it experiences is also 0. If the charge is moving at an angle, right, what happens is we can then calculate the theta between the angle and the magnetic field line, and we can calculate the force acting on the charge, whether it's positive or negative, by using the equation F equals to QVB sinus of theta. And obviously it experiences maximum force if the charge is moving at a perpendicular angle to the magnetic field line. So if B is the magnetic field line and V is the direction of movement of the charge, the angle between them is like 90 degrees, then you can assume that F is at its maximum amount because the sinus of 90 degrees is equal to 1. So you can calculate the maximum force by simply multiplying Q, V, and B. Now, one of the most common things that we use with QVB and finding the force on the magnetic on a moving charge, as well as later on when you use when you can find the force on the moving charge in the wire, is understanding the direction of these movements using the left-hand rule or the right-hand rule. Right now, we're not going to be talking about that, but we're going to go ahead and take a look at a simple example where you have to find the essentially the amount of force on a moving charge. So let's go ahead and do that now. Let's say, for example, we have a proton that moves east with a speed of let's say 4 times 10 to the power of 6 meters per second. So we have a proton, which is a positively charged particle, that is moving to the east with a speed of 4 times 10 to the power of 6 meters per second. This proton is moving in a magnetic field that is directed into the page. So we have a magnetic field that is directed into the page with a magnitude of 2 times 10 to the power of -4. And when it's directed into the page, you can imagine something like this. So basically the angle between the force and the magnetic field is still 90 degrees, because actually the magnetic field is like going into the page while the charge is moving in perpendicular with that direction. So theta would be 90 degrees. So what they're asking is essentially, what is the magnitude of the force acting on this charge? So what is F? Now, we did say initially a proton. We know that the charge of a proton is 1.6 times 10 to the power of negative 19 coulombs. It's the positive version of an electron. We're just trying to look for F. We know that F is equal to QVB sinus of theta, right? Now, theta here in this scenario, because the magnetic field is directed into the page and the proton is moving east, it would be 90. The sinus of 90 is just 1, so we have F max. F max is going to be equal to the charge of the proton multiplied by the velocity of the proton multiplied by the magnetic field intensity, which is 2 times 10 to the power of negative 4. So the maximum force it would experience would be equal to, let me just calculate that. It would be 1.28 times 10 to the power of negative 16 newtons. And here we go. You just calculated the force on this proton. Now, you could also be asked to calculate the acceleration of the proton in the magnetic field. And so if I was to ask for the acceleration, or if a question was to ask for acceleration, you have to keep in consideration that you can use Newton's second law, F equals to ma. Here we know the, sorry, I just scrolled up. Here we know the force of the electron. We just found it in the last part. And usually the mass of one electron is about 1.67 times 10 to the power of negative 27 kilograms. So we can go ahead and say that the acceleration, if we rearrange this formula for A, just divide both sides by m. Acceleration is simply force divided by mass. So it's going to be 1.28 times 10 to the power of negative 16 divided by the mass, which is 1.67 times 10 to the power of negative 27. So acceleration is simply, let me calculate that, 1.28 times 10 to the power of negative 16 divided by 1.67 times 10 to the power of negative 27, somewhere around 7.66 times 10 to the power of 10 meters per second square. And there you go. Thank you for watching.